Welcome. In this lecture in linear data analysis, we'll explore validation of regression, and in particular, validation of linear regression. The main concepts are that validation is the way to assess linear regression. Cross-validation uses subsets of the data. One particular method of cross-validation is leave one out, in which we literally leave one example out and we train on the remaining examples, and then we test on the one we've left out. This is computationally complex. K-fold cross-validation is common in practice, and this requires a little more study. One problem that we can think of as we go through this lecture is how good is a linear regression from our given data? Let's begin by recalling some terms. Each observation is some vector that the user provides us with. We form a data matrix using m observations and n variables. So this data matrix, each row has n entries, and each row is an observation that was provided to us. The data may or may not require transposition, which is seemingly an internal problem in machine learning. A linear regression is taking these dependent data and then some additional dependent data and attempting to form a linear relationship between the two of them. Depending on our model and depending on our data, we may want to standardize both the data matrix and the data vector, and that gives us a standardized problem, which is what we'll often solve using linear regression. When we go to validate this, the validation is the process of confirming that the outputs are acceptable. And in linear regression, what that means is we've got the independent data in the matrix X, the dependent data in the vector Y, and we want to compare the regression. So the regression depends upon a proposed solution W, which is the weight vector. And the usual way to do this is to measure the root mean squared error of the data matrix, the data vector, and the proposed solution as this root mean square. And here, instead of writing it as sum of squares, we're writing it in terms of the transpose of vectors. This measures the fit, and let's emphasize this is the fit of the model to all of the data we have. Now, let's explore ways that we can do cross-validation.